Let's see. Kind of just pop back in here, make sure that we're live, everybody. There we are. I see Brian Jones in my YouTube feed. I love it. I love it.
Good afternoon.
So all right. So everybody, this is Dan Bigman, and I am your GPR professor from learngpr.com. And today we have Brian Jones in the GPR hot seat. I'm very excited to have Brian with us today. We're going to go into kind of an introduction for him in just a minute. I just want to make a couple announcements. If you like us doing these interviews, then please click the like button for this video and subscribe to the Learn GPR YouTube channel. We're going to try to bring you more interviews. We asked people if they wanted more interviews, and to like last time, we got the highest number of likes that we've gotten, on a video. So clearly people want the interviews. And what did I do? I came back with another excellent interview for you guys from an excellent guest from GSSI. So number one, like the video. Number two, subscribe. And put in the comments below other topics you want us to kind of bring you interviews on. But we have kind of a list of people coming up soon over the next couple months. So I'm pretty excited about that. Second announcement, we are in pre-launch for a book that we have coming out later in the fall. And if you have not heard about it, please go to learngpr.com/books. learngpr.com/books. Very simple. I do everything really simple. Just go there, and we would really appreciate if you pre-ordered a copy or two. To help support kind of our initiative. So with that said, and there's a link below to the site. But with that said, we have Brian Jones from GSSI, and I've known Brian now for almost 10 years. It's wild to think about it. Probably at least 8 years, I think.
Yeah.
So I've known Brian for almost 8 years. He, he's been doing this for a long time. He's obviously from GSSI, manufacturer of ground penetrating radar systems. As well as other geophysical system, instruments that we'll talk about in this interview. The reason I wanted to have Brian on was he has recently published an article, and really recently published 2 articles that I got a lot out of. And so I wanted to kind of bring him on here to talk about the concepts of them. Is about best practices in GPR for utility locating, but I think it applied to the industry. The other one that he did, different together, both effective, programs. So I'm glad that he came on. I'm really, really appreciative that he was willing to sit in the GPR hot seat and give us an interview today. And before, I'll let Brian talk about his background a little bit. I'll give everybody a story about kind of how I met Brian. We had met, I guess it was at a conference, and we had interacted a little bit, and they sent me this is kind of an embarrassing story from my end, but they had sent me on loan, and it was an EM profiler, it was a conductivity meter, and it was an awesome piece of equipment. I got to play around with it a little bit, but of course, the day before I have to send it back to GSSI, they did their part and I didn't do mine. I lost the data logger. Okay. So I had to call, Brian and Dan Welsh and some other folks at GSSI, kind of tail between my legs, and say, I'm really sorry. I know I just lost your data logger. What can I do? And they said, no problem. Buy another data logger, stick it in the case, and we'll be, all good. So Brian, since then I've appreciated, the flexibility that you and Dan and GSSI has had and all of my stuff. And so that's kind of my intro, to meeting you. But why don't you give everybody, because you've been doing this a while, why don't you give everybody your background and tell them all about how you kind of got into GPR and geophysics and kind of what your role is over at GSSI.
No, sounds good. Yeah, the video and stuff is getting a little crazy here, but I'll roll with it. Hey, I appreciate you having me here for this interview. Yeah, my background, I went to Boston College for environmental geoscience. I worked for about 7 years for a consulting company doing ground penetrating radar, EM, seismic, resistivity, all the geophysical suite. And then I've been here at GSSI working as an application specialist. for the last 10 years or so. I mainly work with customers that do environmental consulting work, mining, geology, geophysics, and any other odd applications that people might have. So it's a little bit of what I've been doing for the last 20 years or so.
Excellent, excellent. Well, thank you so much. So New Hampshire's not all that far from Boston, so it's kind of in the same general area. So you don't have to go too far, I guess, to get over to GSSI. Are you from Boston originally, you said?
Originally, I grew up in Connecticut. Yeah.
Oh, Connecticut. Okay. So Northeast area, kind of stayed pretty close to home. I married a Puerto Rican woman, and she required me to move further south. So I had to leave the Northeast, but I miss it. I miss, like, especially this time of year and coming into the next couple months, I miss the fall up in the Northeast. It's an incredible time. All right, well, let's jump into it. So your first article, that I wanted to talk about was the best practices for ground penetrating radar professionals, right? I've done a number of these kind of, short videos, talked about best practices or what people should do. And we actually have like an entire section in one of our courses about best practices. I almost feel like that part isn't driven home enough, for GPR professionals about, how do you handle projects, beyond the system itself or beyond the actual survey, right? How do you approach projects? How do you kind of get a successful, a project going? How do you, deal with all this stuff? So why don't you run us through, the kind of few things that you spoke about in that article?
Yeah, so obviously, I mean, as you know, and you're posting a number of videos. There's obviously a lot of things you got to consider when doing any type of geophysical survey, whether it's radar, EM, seismic, etc. Is it the right tool? Am I doing the proper setup on the system? Knowing your targets and the materials you're working in, choosing the right. I mean, in the case of GPR, using the right antenna. For EM, it could be the right frequencies, et cetera, et cetera. So really, mainly survey design, system setup, and kind of knowing kind of your equipment, basically.
Mm-hmm. Yeah, okay, that's I agree with you. That's excellent. Some of the things you talk, is like finding the right frequency antenna, right? In the article, that's kind of one of like the 5 best practices pieces that you go into. A lot of people that I have found, sometimes they'll get like a instrument with a single antenna, and we certainly would prefer people to buy, a GSSI, GPR with a single antenna than not to buy a GPR, right? So we're not going to fault them for getting it with one antenna, right? That's like the most important. Is if you're not getting started, then you're missing the boat. You're going to lose out on project successes. You're going to lose out in the marketplace. So you got to get one, even if it's with one antenna. But for people who can get systems that have multiple antenna, how do you go about choosing maybe the right frequency? And kind of, I'd love to hear your point on that. And is there any sort of rule of thumb, of, well, our targets are this deep, or this is the kind of physical properties of the materials that we're in? How would you guys approach that?
Yeah, I mean, you bring up the thing with a single versus multi-antenna systems. GSSI, several other competitors, have dual frequency systems. There's some out there with triple frequency and more. I mean, for a number of years now, people have been doing it with single frequencies successfully. So, some of the multi-frequency systems in terms of a push cart configuration, sometimes it's helpful, sometimes it's not. I mean, I've done surveys even with our own system where, you have 2 antennas, the high frequency antenna, maybe it's not seeing that deep. Maybe it provides almost too much resolution where a novice user, they're seeing every little rock, cobble, tree root, everything that's down there. It makes it more difficult to interpret the data often than just having a single frequency. So, but
sure.
in terms of knowing your frequency, and that's going to depend, right, on the soils. People usually want a mid-frequency antenna. When I say that, probably somewhere between like a maybe 250 and 500-ish megahertz. GSSI does a 350, a 270, a 400. I mean, we got several in that range. And it's going to depend on the soils, you know. I mean, those,
So
yeah.
yeah. So okay, so kind of a follow-up question to that then is, you make a really good point, right? And so certainly if you can get a multi-frequency system and it's the right system for you, right, as the user, that's fantastic, right? Because you get the high and you get the low, and sometimes the high is just right. It's such a high resolution. You're seeing every little detail. It's almost overkill. But let's say you get another system, where you're using a single antenna, but let's say you can swap in and out. Like you say, the 270, or you can put in the 400, or you can put in, a 800 or 900 or whatever the case may be. What are the factors that, you would use to kind of define, all right, I'm going with a 400 versus I'm going with a 270 or a 200, right? Look, if people know the very basics, they should know, and I've seen people who fall short on this, but they should know that the 200 is going deeper than a 900, right? I mean, that's pretty basic stuff. But what about when somebody has a unit and they have multiple different antenna and they're kind of trying to define, well, should I go with my 400? Like let's say we take one of the GSSI systems. We have a SUR 4000. You can use one antenna with it, but I have a 400 and I have a 200, right? And when is that sacrifice, right? Because you're talking about best practices, right? So when is the sacrifice for resolution, acceptable for depth? And I don't know if I have like a hard and fast rule, right? It's a complicated thing. I'm trying to pick your brain from your experience. Kind of when you get closer in range to that, like a 400 versus a 200 or a 400 versus a 270, what kind of factors, would you take into consideration? Or what do you think the best way to approach it would be?
Yeah, I mean, hey, really, I think the bottom line, the easiest way to answer that question is you want to be able to use the highest resolution antenna that gets you the depth, or at least slightly beyond the depth that you need, right? I mean, the more resolution you can have at the depth you need is better. So, but, as soon as you start running into tougher soil conditions, more clays, more silts, maybe shallow water table, now you have to start combating that with some lower frequencies. It's just the nature of the beast, right? So, you'd hopefully, I mean, as a general rule of thumb, I mean, kind of across the industry is things you're hoping are going to be about 1 inch in size per foot of depth. I mean, it's obviously a crude rule if something's metallic or whatever, but so, something at 8 feet, you're hoping it's 8 inches in size or somewhere in that ballpark. It's not always
or higher, right? Or larger.
Right. So, but as you start going deeper and deeper, then, if you try to go to a 200, you might not have the resolution you want and things like that. But I think, if you have the option, sure, hey, you try a couple antennas. I think, most folks, when you get out there, you're setting up a system, you're looking at your initial setup screen, or maybe you collect a couple test scans around the property. And you can see pretty quick, if you've used the system a handful of times, about how deep you're seeing, where the noise is coming into the data, where you can't see good quality information anymore. And if you have to push that down with a lower frequency antenna, or maybe a newer technology antenna like our 350HS, it's a good way to look at it.
You bring up an excellent point, which I've talked about in the past too, and I think you say things more eloquently than I do. So you bring up the point of how long should you take for setup, right? And when you're talking about best practices, I think this has got to be in there, right? Now, projects are going to dictate what your time budgets are, right? Money budgets and time budgets. But almost I feel like people should maximize the allowable time for setup that they have, as opposed to we have this extra time, we can save time. Maybe the wrong approach, right? Maybe the right approach is we have this amount of time, let's use the maximum amount we have to test out different antenna. Like put one, like you bring up a great point. Highest resolution at the deepest you can go.
Definitely.
And so you start high and see what depth you're getting. And if you're not getting it, you switch it out and you get another one in there. So you start with a 400, it's not working out, you put in the 270. You have the 270, you swap it out, you stick a survey wheel on, go with the 200, right? I mean, you kind of incrementally go down if you have the ability to do that as far as time goes, and assuming that you have potentially multiple antenna. I think there's a great way I think it's a great way that you put it, and absolutely makes a lot of sense, right? And everybody should. That's going to be so we did the last time we did this. I gave I did a contest. So I will give somebody a free 30-minute coaching call, just me and you. If you tweet out to @LearnGPR, tweet highest resolution with deepest, with greatest depth. Highest resolution with greatest depth. If you tweet out that to the first person, because the last time we did this, I had like 4 people who told me that they were winners, and there wasn't. There was one winner. So the first person to tweet at me, @LearnGPR, highest resolution with greatest depth, gets a free 30-minute coaching call from me personally. But that's a great way to put it. And I'm gonna say it like that from now on, because it makes a lot of sense, right? You want to experiment, you want to get the right thing in there, but you should start higher up and go lower and lower until you've met what you need, right? Your requirements for depth with the best resolution that you possibly have. It was a great way to say it.
I mean, I can add a little bit to that. I mean, one other thing I had in my article on best practices is, gathering a lot of information on the site and the conditions beforehand, right? You might give yourself a much better idea of the antenna you may need. You may not need to bring your whole arsenal out there. You may not have a whole arsenal. Maybe you can check ahead of time and see, boy, the conditions on, the U.S. Soil survey maps, for GPR suitability, say it's going to be not that great of conditions. So if I need to go 8 feet, maybe my 400's not going to work. So maybe I should rent the 200. Maybe I should bring what else I have.
Yep.
Or maybe it says, hey, you really shouldn't even be doing GPR in that area at all. Maybe you need a EM out there or some other technique, right? So, doing a lot of investigative work beforehand, as-built maps, checking with local folks, maybe checking driller logs. There's even apps you can get on your phone. There's an app called Soil Web. You can put it on your phone wherever you are. You can look up basically the U.S. Soil Survey, soil section for that area. And I mean, it gives you a pretty good indicator of how well GPR can work. Yep,
absolutely. It's a great point that you make. Archival research, do your homework, right? We know, and look, GPR is complicated enough, right? It is a difficult technique in many ways, right? And I say that because there's so many factors that can influence the quality of the data or the success, of a particular project. Is that the more information you have is just going to help you achieve that success, at a differentially greater rate. And so the more you can do, absolutely. And that Soil app is great. I mean, I use one that's like on top of Google Earth. And you basically just click in and it gives you like a core that was done in that area.
Yeah.
And now again, if it's in a parking lot, you don't know if it had fill in it, but like it's an indicator. It's more than you had, 5 seconds ago before you clicked it. And unfortunately, to my knowledge, everybody out there who's from not in the U.S., I only know of it being in the U.S. I had people from Australia reach out and said,
Sure.
"Oh, does this in Australia too?" Unfortunately, I haven't found something like that. So you're out of luck. But for folks in the U.S., you should have that. I mean, that should be a go-to tool because it's very quick and it gives you some sort of indicator. All right. Well, so moving on to another piece of the best practices, what you had in there. So you definitely hit frequency on the antenna. You hit doing your homework and investigating the site before you investigate the site. Right. That's really what it is. Investigate the site before you investigate the site. Is you talk about almost like system parameters, right? Like kind of calibration of the system. Now, different GPR give you different kind of control over what you can and can't do. Certainly even right with, and this is, I think, across a lot of different of the manufacturers, with GSSI, same is true, right? Surf 4000, and I don't have that much, I don't have that much background or use with the new system that has the 350 on it, but it has a tablet, right? Or even like the DF, right, which has the tablet. It's limited functionality as compared to like a Sur 4000, right? To something that has a lot of dynamics to it that you can, you have a lot of control over. So for people who don't have that much control, what would be the parameters that you would say are some of the most important ones that people have to get right, on a site before starting work, right? So there's hundreds of things you could do. What are the, or tens of things you could do? What's the few that you think are the most critical that people kind of should internalize and, make part of their program every time, they go out to kind of a project site?
Yeah, so you're right. So I mean, there's all kinds of systems. There's simple to use systems. All the manufacturers have them. We all have pro level systems where you can multiple antennas, change settings. We have the easier to use interfaces. If people are only doing utility locating, environmental assessment, the basics, even handheld concrete inspection systems. There's a few basic things you need to check and do, but we've really simplified it down and made it easier for everybody to use. But really, the things you need are, in my mind, would be you got to make sure you're looking deep enough, and you got to make sure you're taking enough scans to find as small of a target you need to find.
Mm-hmm.
So we always say, even in our training department, you want to be setting your system deeper than what you really want, right? Because I mean, the soils could change, the concrete can change. If you need to look, 5 feet, don't set the system up for 5 feet, because there's some other variables in there that you may not be getting 5 feet, right? So set it up for 25, 50% deeper depth, just to account for any variability. So that's one thing I'd say, aim it a little deeper than what you really need, and then take enough scans, right? I mean, on some systems that might be low or high scans. It might be low, medium, high. It might be something like that, or you may have full flexibility. I would think that in most user guides, you should be able to find out what low, medium, and high scan rates are. I think all the manufacturers have done a pretty good job of setting those parameters up for what's the most common settings and best settings for utility locating. So, but the smaller something is, the more scans you have to take, right? I mean, it's fairly simple. So, if you're looking for a 48-inch main, you're not going to need 60 scans a foot or something like that.
Right.
You could get away with 6, 12, something like that scans per foot. But if you're looking for that little 1-inch conduit, something like that, fairly shallow, then, you're going to need to take enough scans. Probably 2 to 3 scans per inch of, your smallest target, I would say. So, you want to make sure you get enough hits on it.
Yeah, no, I think you're right. Sometimes I think about like physical parameters on this, but almost taking it down to even more basic, like you say, is if you're not looking deep enough and you're not looking often enough,
right,
you're gonna miss it, right? And that's the truth is it needs to go down to that level even to begin with, right? And so it's a very good point. And this goes beyond what we were talking about before about getting the right frequency. Is once you have the right frequency, you could screw yourself by not going deep enough. I mean, we had a client, we do like project support, and they'd already gone and collected the data, and they told me that their targets were 12 feet deep, or something like that. And they were trying to ask me to find the targets, and I was like, I don't see them. I said, how long was your window open? And they said 45 nanoseconds or something like that in two-way travel time. And I was, well, that's the reason right there that I'm not seeing them, right? If you could see them at all, right? If you even got the frequency right to go down that depth and the physical properties allowed it,
right.
You can't even worry about that if you're not even looking deep enough. So understanding how to do some basic calculations of, well, how fast is it moving, and and how deep am I trying to look, and what will that, what do I kind of have to open up as a window, is important. As like you say, as well as the scans, is getting it right, to where you're looking at enough, you're taking enough readings, frequently enough to see them.
Yeah, I mean, in terms of the depth, yeah, in terms of the depth, like you mentioned, yeah, I mean, you should be looking at the soil properties, right? And a lot of the systems, you have the ability to choose just a soil type. Is it sand? Is it an average soil? Is it a wet soil? Is it, some of the systems allow you to pick that, kind of gets you in the ballpark, and then, you pick your depth from there. Sometimes you're picking up velocity or a dielectric value. That's something you can probably find in the manual, or there's some empirical values you're picking from. And then once you get yourself in that ballpark, then make sure you're setting up for enough depth. Because like you say, I mean, 45 nanoseconds, that might have been good enough for 12 feet if it was a dry sand, but
maybe, right? I mean, right, yeah.
But you got to get yourself in the ballpark first, and then set your depths, like you're saying.
Yeah. P.S. It was wet clay, and so the thing was moving as slow as possible. and it wasn't happening, right? I mean, on that day, I said this recently. I said I can find anything you want with GPR once I can change all the physical properties of the universe, right? When I can bend them to my will, then I can find everything with GPR. But until then, I'm still constrained like other. And I say I'm superhuman, right? So I'm superhuman, but there's still limits to even my special powers. So and bending the laws of the universe are not one of them. So you're right. I mean, you're absolutely right. One thing that you didn't discuss in this article, which was, and by the way, everybody who's watching, I put links to both of Brian's articles in the description, to this video and to the summary of this video. And I highly recommend you go read both of them. They're pretty quick reads, but there's a lot of value in each of the articles, which are like the best ones, right? You get a lot out for a short period of input. I would recommend that you read both articles. So the links are below. But something you didn't talk about in the best practices article, and again, constrained by time, and space, but you wrote in a different one, which I think is important, is, using multiple different sensors, right, in order to characterize a site, will give you a better, option than just, or better, likelihood of understanding what's going on than just using GPR. I'm going to give an example of I literally had earlier today on a coaching call, is they identified a target that was buried, right? So once we got through that, yes, it was an actual buried feature and not something that's on the ground surface, a tree or something like that. All right, it's there. Well, the next question is, well, what the hell is it, right? And so in this case, they were looking for a void. And while GPR can certainly identify it, an easy way to kind of go check that would be for them to bring in either EM conductivity, right? It's something that would be highly resistive, right? So have a low conductance, or bring in, earth resistance, or bring in gravity meter. I mean, it was a geological kind of thing. And so, so enhancing things with multiple sensors is so important. And I think you hit, the point. I think I literally use in like my sales pitches. Okay, some of the points you bring up in your second, in this article, in Trenchless Technology, because you just look, you define them really simple, and they were very compelling arguments that you make for the benefits of it versus not having the availability, right? So why don't you kind of walk us through what some of the benefits are to using multiple different systems?
Yeah, so boy, there's a number of geophysical tools out there, right? And really, it depends on the type of application, what you're looking to get into. In the world of utility locating, we would recommend everybody have GPR and some sort of pipe and cable locator. Is it some sort of RD system that can radio detection? You can clamp on, you can do that. It's almost a no-brainer. I mean, if GPR is not working great, you use the pipe and cable locator. Pipe and cable locator is not going to find everything because everything's not conductive. So those are good partners. But beyond that, there's other tools out there. I mean, for environmental, something like an EM induction system, whether it's our profiler or other models, you can cover so much more area than GPR. So I mean, if you have a 5-acre site, something like that, you want to cover that whole area. If you try and bid that out just using GPR, you may lose that project because it's going to take you a week, to do it. Where, you could go out with EM, maybe even a magnetometer. If you could partner with a magnetometer or EM, go out and you can just walk that area. These systems aren't dragging along the ground, just, like GPR. Walk very quickly. They're tied in with GPS, most likely. Get your whole area done very quickly. I usually say, doing about 5-foot grids with GPR, you can do maybe about 1 acre a day. With EM or a mag on the same level, you could probably do about 5 acres a day. So you can go out, get this all done, and with those technologies, they're not perfect either, but you're going to find usually anomalies or hot spots that could be buried metal, buried debris, landfill boundaries, debris pits, all kinds of stuff. And then from there, you say, oh boy, I got 1, 2, 3, 4 hot spots. Now I go out the next day or whatever, and I focus my GPR on there, because the GPR is going to give you the depth information, better size information, and give you more detail on what's going on. So it's a good way of crunching down the time that you need to be out there. And I mean, like I put in the article, I mean, sometimes people think of it and say, hey, boy, why do I want to cut down my time? Because I'm billable, I can make more money. But you may not get the job if you bill it out at a week. Somebody else doing multi-techniques will, and you get out there, you can do more jobs that way. You get in front of more clients. You save clients money. That builds your reputation. And that's, a lot of these folks in small businesses, I mean, you really rely on your reputation. And so I think you provide a lot of value for people, and it goes a long way.
Yeah, 100%. I mean, look, there's definitely ethical concerns, that you brought up as well. And ultimately, right, we want everybody to kind of have the outlook of, what's best for the client, what's best for the project, what's best for the community around it. Because a lot of times this stuff has to do with, damaging things like gas or, water mains, right? Things like that. What's best for all the stakeholders involved, right? And usually that, drives what your strategy should be. And you make a really good point, right? So whether it's utility locating and you're using like an RD system, or Vivax or whatever first, and then you go in with, I know people who will go out and they'll do that, and then they almost exclusively use GPR just to run over it to make sure that their depths are accurate, right? Because they feel like the GPR is going to give them more accurate depths. Okay, so even if that's the minimum you're doing, it still is a big time saver and shows the power of two systems, right? Two different geophysical systems. But with like an EM conductivity and GPR, right? Same thing. I mean, you can cover a lot of acreage quickly with EM, find targets, assuming that they're large enough where your resolution is going to be appropriate. But you can find these targets, then go in and get some other information with a GPR like depth. Or the nice thing is, like, you can go in and literally extract a 3D model in many circumstances of just those targets, right? Sometimes it's funny to think about. I never think about it this way. How much GPR data is sitting on computers right now of nothing, right? Of things that were never relevant to a project. You still got to do it. But if you take the approach that you just said and you go out with an EM first, you cover a lot of area, and then you go in with the GPR to these hot spots that you can kind of focus in and get the three-dimensional view. You're focusing in the three-dimensional view, right? And then it's a good multi-tiered approach towards capturing more data, and then, like I said, being able to characterize it. Because look, the way GPR works is it doesn't tell you, in a sense, right? I mean, people can argue with me. Go ahead, argue in the comments if you don't like what I'm going to say. In a sense, it doesn't tell you if it's conductive or resistive, right? I mean, you can make some arguments at a very high level that's looking at water versus air anyway, but for the 99% of people who use it, that's not really what we're doing. EM conductivity, however, can tell you that. So these are two different properties, right? One is telling you how fast or slow the wave is moving, and we'll have that kind of transition. The other one's telling you how easy or difficult it is to induce an electric current. And with combining those two techniques, you're really combining two different characteristics of the subsurface, and helps you, define what a target may or may not be. Because if you can create or generate expectations, okay, we found some hotspots, and these are not conductive, they do fit our expectations for a void. Or on the other hand, right, we found some hotspots and they're very conductive. Well, what could that be, right? Well, maybe they're metal, right, or something like that. Can help you begin to define them. Okay, now let's go in. May be our target that we're looking for, or may not be, and hit it with with a GPR. I think there's a lot of benefits to it. A lot of benefits to it. One thing I really liked about your article, if I remember correctly, I read a lot, but is I feel like you put a few numbers in there as far as like, what does a borehole cost versus what is GPR and EM cost. Now that's going to vary across the world. It's going to vary from industry to industry. But kind of just take us through like the general math, of it. Again, you don't have to use the same numbers or anything like that, but kind of, I liked how you broke it down to say, look, here's kind of what a borehole is going to cost, right? You plus or minus, here's what a borehole is going to cost. Here's what GPR is going to cost for an acre. Here's what EM is going to cost for an acre, right? And it just was easy to lay out that, it's not a replacement for borehole necessarily, but it's a complement to it where you can actually get a lot more data, a lot better resolution, still get some boreholes in the ground, but actually still come back with lower costs, right? I mean, kind of walk us through that process.
Yeah.
How should people be approaching that kind of with clients and project, proposals?
Sure, yeah, and I think you know, a lot of this even comes from the contractor side, the people who are hiring this out. This is good info. So I mean, uh, that's kind of how I started out that article that you're talking about, and I kind of outlaid it saying, you know, traditionally people on these environmental sites and construction sites related, maybe you're doing shallow geotechnical engineering. You're looking for shallow bedrock, maybe for environmental, you're looking to map the bedrock to see where the dips are, where contaminants may be pooling. And a lot of times, you know, these environmental folks, you know, they're kind of trained to just go out and poke boreholes. You know, where's the problem? You know, and that's good because I mean, they need to sample the soil, vapors, and all that, and you're still going to do that. But you know, rather than poking Swiss cheese out of the place, you know, and doing 20, 30, who knows, hundreds of borings, you know, you might have a site where you can go put one or two borings, or maybe you do the geophysics beforehand to plan where to put your borings, and it may be more beneficial. But a lot of these techniques, I mean, GPR, if the conditions are good, you can get, you know, nice top of bedrock profiling, soil layer profiling. You can really know where to put your borings. A boring, at least in the U.S., you know, you're probably looking at anywhere from $5,000 to $10,000 on average for a typical depth environmental boring. For a typical geophysical survey, depending on where you are and who's doing it, maybe 1,000 to 2,000 or 3,000 a day. You know, you can only do so many borings in a day, but you can cover a pretty good chunk of a site with geophysics in a day. So you're quickly dropping down costs, you know, do more geophysics. You're getting continuous profiles rather than just point measurements, right? You go out, you drill a borehole, you say, oh, I see this, this, and this. The bedrock's at 20 feet. Well, then you move over and you start doing your work. Oh, we hit rock at 5 feet because, you know, here's a pinnacle of bedrock over here that we didn't know about. So it's providing you much better coverage of the site in terms of information for less cost. You might be able to do a borehole and compare your GPR because, you know, like you say, GPR can't tell, is this a layer of sand? Is this top of bedrock? There's some things you can do with experience to kind of tell, but, you know, now you have your borehole, you say, oh, that horizon I see in my GPR data, oh, I see that right here at 10 feet in this borehole that I just went by, I put a mark in my data, boom, now you can match it up, you can calibrate your GPR data. It goes a long way. So, you know, and there's all kinds of techniques. I mean, you know, maybe GPR is not it. That's kind of what I went through. You know, maybe there's seismic, maybe there's electrical resistivity. There's all kinds of stuff. But, you know, in talking about GPR here today, it's going to be the fastest technique. It's going to be the cheapest technique. It's going to be the highest resolution geophysical technique for your money. So if it'll work and you know, for your project, it's definitely the way to go.
Yeah, absolutely. I agree with you. You know, and I'll say, you know, having some sort of, you know, these alternative techniques, including with even with EM, right? Even EM, you know, we can expand on you know, from GPR certainly is EM itself can allow you to kind of minimize the number of boreholes that you might need to take, right? And we're talking about resolution. Sometimes with these larger environmental projects, if you're looking at broad kind of variations in the landscape, because you're looking at contamination or you're looking at groundwater, you know, or things like that, the coverage that an EM can give you to allow you to kind of, you know, fill in the gaps or, you know, between your boreholes is a tremendous amount. Like you say, I mean, for $2,000 a day versus maybe $5,000 a borehole, but you can do 5 acres of, you know, of an EM survey in a day. It's phenomenal, right? And I'll just say, just as like a, you know, a point of reference, something I like about the GSSI, a lot of letters in there. The GSSI profiler is, I like that you can kind of do, you know, change the frequency, right? Use what's kind of appropriate for you. I have used the profiler before. I literally did a project one time. I used 4 different frequencies on a GSSI, you know, conductivity meter. I actually think it was the old school, the orange sled, you know,
300.
GM 3000 or whatever it was called, right? But the same concept, right? The same principle was there, which was, you know, that you can use different frequencies. And I've used on a number of projects where I use 4 different frequencies, and it was never the same frequency that worked out well. You know, I mean, there's, you know, there's a debate, you know, as to how the sounding actually works. But what I have found from personal experience is I've never gotten the same exact frequency as the right frequency for every single site, right? I've always found different frequencies perform better on a particular site condition. And so I liked that about your connectivity meter, where it allowed you to kind of choose a frequency or a couple of frequencies, and go ahead and collect the data, and then decide afterwards, right, which one was like most appropriate, and you have it, right, and you have it available to you. So that was definitely a feature that I really enjoyed about it. But kind of to take that and transition to the future, will EM conductivity, will GPR, will any other geophysical survey method ever replace? Like, do you think you'll get to the point, getting deep into the GSSI mind of you now, right? I mean, as you have what's kind of coming is there ever going to be a point, do you think, that this stuff will destructive processes obsolete, or do you think there will always have to be some level of breaking ground, I guess I'll say, to use it, use that kind of term, to put in with the geophysics to get hyper accurate understanding of at least composition of what's going on below the surface, or whatever? I mean, where do you kind of see the future?
Yeah, and partnering these geophysical techniques does help kind of weed some of that stuff out. So, I mean, when I used to work in consulting, when we would do, a bedrock survey, a client would want to know, how deep the bedrock is. Either they want to put in borings, or they're putting in a foundation or something like that. We would partner GPR with seismic, and you would do GPR over the whole area, and then you would do maybe 1 or 2 seismic profiles.
Mm-hmm.
You have kind of confirming techniques. So you can say, oh, in the seismic, yep, okay, right here we're seeing top of bedrock, which is a little, more obvious to tell in seismic data. It's at 15 feet, and then you say, okay, yeah, we got that nice horizon at GPR, 15 feet. Now I can follow that around the whole site and really do all that. So that helps kind of eliminate the need for borings by doing a couple techniques like that. In terms of combining other techniques, like for utility locating, GSSI now has the combined techniques of GPR with the pipe and cable locator. It's called our line track system. So you tap that right in with your antenna. It can work with any of our data loggers, basically, and you're going to get power mode. You're going to find live electric lines. You're going to have the ability to clamp onto lines and see that response in the GPR data. So it's good at differentiating things. So if you're thinking about potholing, you're thinking about, oh, I'm really just looking for the water line because we have to replace a leak or something like that.
Right.
You can clamp onto the water line. Now look, you might have some issues with, signal on if you just use an RD, but now you go along with the radar. You're seeing multiple hyperbolas in your data, but you see a response only on one of them. You say, oh, okay, it's not this one, or this one. It's this one right here. That's my water line. This is really where we need to dig. Whereas if you had just one or the other, it would be a lot harder to figure out.
Mm-hmm.
So I think a lot of the meshing of the technologies and things like that is happening.
Yep.
And probably,
I think, again, right, coming from my background, I agree with kind of what you're saying. I definitely think it's application specific, right? So if you start to look at like archaeology, for example, I don't know how there would be like a removal of destructive processes at all, right? Because we're talking about layering and finding artifacts in order to date layers, right? So you'd have to get some of that stuff, I think, right? But I think you make a good point where, at least in some other industries, there probably is on the horizon, maybe it's 10 years, 20 years, whatever, at some point, right? When you think about human history and then where we are and how much time we have left, is this probably will continue to be, because I think there already is, but a continuance of the trend towards a reduction in destructive, even look, your paper was literally in trenchless technology, right? I mean, the horizontal boreholes that they're doing now eliminate a significant need for large excavations to bury utilities. And so that trend is clearly coming. And I think you're right, with the multiple techniques, it'll continue to reduce it. I don't know if we'll ever get fully away from it, but the more you can characterize what's going on, the more you can identify individual targets, with multiple techniques, it'll definitely eliminate the need for so many right? Boreholes, excavation units, test excavations, or destructive kind of, methods. So I definitely am in agreement with you. The trend is for sure towards less aggressive, means for detection.
Yeah, and I think a lot of it too, like you're saying, it's going to be application dependent. I mean, if you're just looking for depth to bedrock, we can apply a couple techniques that we can get a pretty good idea that that's bedrock, and you can run with it without the need for borings. But some applications, like you say, like archaeology and some other things, you're going to want some confirmatory info, and a lot of it's peace of mind too. I mean, some people don't really trust geophysics. Some people don't trust the person interpreting the geophysics per se. Some people want that hard evidence that says, okay, you did my whole site with your nice geophysics, but I want to know that for sure is what we're looking for, and that that gives clients a peace of mind too. So whether that'll ever go away, I think it all depends on the trust factor too, right? It's a mind thing.
Yeah, when the nanobots, have the GPR stuff on them, and they're crawling through the soils, and they can take the soil sample, do it, and do the GPR on, and the whole night, then maybe we can.
There we go.
And that may come, but the trend is for sure, in that direction. Non-destructive, damage prevention, non-invasive, is great, right? The less you can destroy, whether it's archaeology, utility locating, concrete infrastructure, any of that, the less you can damage, the less you can destroy, I think the better everybody is. The truth is, there's also a lot more safety issues, right? Just kind of another point with excavation than there is with pushing a GPR around. Okay, so that's a big piece of it too. Is it certainly increases site safety?
Big time.
I think it's important. So, all right, well, that kind of wraps it up. And I want to just say thank you so much to Brian. I want to say thank you to GSSI for taking the time to give us awesome information. So everybody who watched this, you guys are lucky that they were willing to do this. Just phenomenal, information for everybody. I hope you all got a lot out of it. I certainly got a lot out of it. I'm selfish. I do these because I want to know and I want to talk to these people. But I just figured it's better for me to do it, in public and live, so everybody else can benefit as well. So make sure you go over to learngpr.com, put your name and email address in so we can send you training videos. Subscribe to the channel, like the video, and like it up because Brian was awesome. So like up the video, and Brian, I just want to say thank you so much for coming on, and sitting in the GPR hot seat and letting me give you some questions. I appreciate it, and I think you brought a lot of value to our audience.
Well, no, hey, happy to help. Appreciate you having me on. Hopefully that was good information for everybody. And if there's anything I can ever help with, people can find me on LinkedIn. It's a good place to find me. Happy to answer anybody's questions. It doesn't have to be from a sales platform or anything. Obviously, we're happy to help people who want to buy GPR, but yeah, happy to help with any advising or anything like that. So yeah, thanks for having me on. Appreciate it.
My pleasure. And everybody, by the way, I did put to find more about GSSI or to connect with them on social. If you go to the descriptions in the link, in the section below, it's geophysical.com. You can go to their website. I have their Facebook page, a link to there. I have a link to their Twitter account, a link to their YouTube channel. So they actually have good videos there that complement the videos that we do at Learn GPR. They have a handful of videos where that actually, and Brian stars in a couple of those videos. Okay, by the way, and I took a photo of Brian, for the thumbnail of this live feed right before it went live, and it's on our channel art now. So if you go there, it'll be up there for at least a few days.
That's
and I will say this: if for some reason Brian does not make it, for another 10 years in the geophysics industry, he has a bright future as a hand model. Because the way that this guy holds the concrete scanner, you guys check it out. He's got nothing to worry about. All right, he's golden. He's golden. So anyway, well, thank you again, Brian. I really appreciate it. Everybody, thank you for tuning in, and make sure you continue to check out these videos. And I wish you nothing but the best of luck.
Same to you, Dan. Take care.